Okay, next we have kind of done our introduction. We will do some of the easier examples first. So here are my steps, and these steps will be listed on every slide, so don't worry too much about memorizing them all. They will keep showing up. My first step is to get both equations in standard form. That means I want all my variables on the left and all my numbers on the right. Then I may need to tweak the equations to get a variable to cancel. We're not going to tweak for the first example, but we will tweak for the second example. What tweak means is I might have to multiply one or both of the equations by number in order to get a variable to cancel. Then once I've got it all poised, ready for cancellation, I'll add the equations together for the third step, solve for the variable that's left, plug that into either equation and solve for the other variable, and then I need to check the answer in both equations. Remember that it's important to check in both equations because I need to make sure that that point is on both lines. Remember that I love to do the graphing part because it really helps you understand what's going on behind the scenes. So go back and look at lecture 13 if you need to really understand what's happening graphically in these. I need to check that in both equations to make sure that point's on both lines. Okay, first of all, get both equations in standard form. Okay, both of these equations are in standard form. I have all of my variables on the left side of the equal sign and all my numbers on the right side of the equal signs. Then I need to take a look at this and look at each variable independently and say, if I add these together, am I going to get a variable to cancel? Well, if I add these together right now, my x's won't cancel, but my y's will cancel. I have a positive 2y on the top and a negative 2y on the bottom, so if I add them together right now, I'm home free. I'm good. So we don't worry about step 2, and we go straight to step 3, which is adding our equations together. X plus 5x will give me 6x. My 2y and negative 2y will cancel. That's what I was hoping. And 8 plus 4 will give me 12. Okay, that's just 6x equals 12. Divide both sides by 6, and I get x equals 2. So I've got half of my answer. I need to get the other half of my answer. I take x equals 2 and I plug it into either one of the equations. It doesn't matter which. So I have 2 plus 2y equals 8. I just use the top equation. Subtract 2 from both sides, so I get 2y equals 6. Divide both sides by 2, and I get y equals 3. So my answer is 2 for x and 3 for y. Now how do I check my work? You can check it against the answer key, but that's not the right answer. How do you check your work? Okay, plug it in for both x and y in both of the equations, not in just one. So for my check, I put in 2 for x and 3 for y. That gives me 2 plus 6, which is 8. So that checks. So that says the point is on the first line. Now we need to make sure it's on the second line as well. So we put in 2 for x and 3 for y. That gives me 10 minus 6, which is equal to 4. So it works. Okay, let's do a problem that is slightly a little bit harder. Not much though. Let's look at this guy right here. Negative 3x plus y equals 1. Negative 6x plus 2y is equal to negative 2. First step, are they both in standard form? Do I have all the variables on the left-hand side of the equal sign and all the numbers on the right-hand side of the equal sign? Yes, I do. Now, if I were to add them together right now, are my x's going to cancel? Nope. Are my y's going to cancel? No. Well, then how do I do elimination? Because if I add them together, I don't get a variable canceling. I don't want to add them together unless I get something to cancel. Well, if we think about that, remember, we are allowed to multiply an equation by something as long as we do the same thing to both sides. So what if I look at that top equation? What could I multiply it by so that I get a variable to cancel? If I multiply the top equation by 2, then my y's will cancel. So this just shows me what I'm doing. It says I'm taking the top equation and multiplying it by 2. So negative 3x times 2 is negative 6x. Y times 2 is 2y, and 1 times 2 is 2. Don't forget to do both sides. A lot of people sometimes forget to do the number on the right, and they know that they need to do it, but they just overlook it. So don't overlook anything. It's important to get all your details in there. Now if I add them together, before I do so, am I going to get a variable canceling? Yes. My x's will not cancel, even though they're similar, they have the same sign, so they won't cancel, but my y's will cancel. So negative 6x and negative 6x give me negative 12x. My y's cancel, give me 0. And 2 minus 2 happens to cancel also. That's not common, but we have had a couple of examples where that's happened. So it gives me 12x, negative 12x equals 0. Divide both sides by negative 12 and I get x equals 0. I'm halfway there. I need to plug this in and find y. I get in the habit of just using the top equation, but you can use either one. It doesn't matter at all. Negative 3 times x, that's negative 3 times 0, plus y equals 1. So that's just y equals 1. So my point is 0, 1. How do I check? I want to make sure I plug it into both of my equations, and I want to make sure that I'm plugging it into the original equations, the ones that were first typed in the book, not the ones after I multiplied by a number. Plugging it in the first, I get 1 equals 1. Plugging it in the second, I get negative 2 equals negative 2. So that says the point is on the first line and the point is on the second line. Therefore, it works. Why was I able to multiply the top equation by 2? I was just doing the same thing to both sides. So we will use that, and sometimes we'll use it on more than one equation, and we'll see that coming up.